Okay, for today's lesson, we'll be covering section 6.5, which deals with solving linear inequalities. And you see in the learning target, it's I can solve linear inequalities in two variables. However, as a warm-up activity, we're going to go ahead and solve inequalities that only have one variable. So looking at problem number one, we're going to go ahead and solve for x. So we're going to follow the rules we learned for solving equations. And that means we're going to go ahead and first subtract 6 from both sides. And then we're going to go ahead and divide both sides by 3 to continue to isolate the variable. Once we're done doing that, we get this as our answer. And reading it from the variable, it says x is less than or equal to negative 6. So we're going to go ahead and graph a picture of our solutions. Here's the negative 6, and we'll go 1 unit above that and 1 unit below that. It is going to be a solid circle. And again, reading that, we said less than or equal to. So it's going to go in this direction, meaning anything from negative 6 and lower than that represents a solution for that inequality. Looking at number 2, we're going to solve it much the same way. We're solving for t here. So first, we're going to have to simplify the right-hand side of this inequality. 2 minus a negative 10 is like saying 2 plus 10, which gives us 12. And solving from there, we're going to have to go ahead and divide both sides by a negative 4. Now, what you have to be careful of here, since we divided both sides by a negative value, we have to switch the inequality. So our final answer is going to look like this. Again, keeping in mind we had to switch the inequality because we divided both sides by a negative. So the answer is t is less than or equal to negative 3. So again, on the number line, we'll put our negative 3 here, and negative 2, and negative 4. We'll have a shaded in circle because we do have equals there. And again, reading it, t is less than or equal to negative 3. So we're going to draw our arrow to the left. Okay, now moving on. We're going to start looking at inequalities that now have two variables, and the directions asked to tell whether the ordered pair is a solution of the inequality. Well, that's pretty simple. All we're going to do then is we're going to go ahead and put the 4 in for the y, and we're going to put the negative 2 in for the x, and we're going to solve this and see if it does lead to a true statement. So when I go through all the work, I end up getting the statement that 4 is less than or equal to, 4 is less than negative 3. Obviously, that is not true, so I'm going to go ahead and put a slash through it. And what that means is when I put the ordered pair negative 2, 4 into the inequality, it doesn't lead to a true statement. So what that means is that that ordered pair is not a solution for the inequality because, again, it didn't lead to a true statement. So second problem here, we're going to do same way. We're going to go ahead and put the 1 in for the y, the 3 in for the x. We're going to simplify both sides, and we get the statement that 1 is greater than negative 1. Well, that is a true statement. So we're going to go ahead and say that yes, 3, 1 is actually a solution. Okay, that leads us to the next type of problem. What we're going to start doing now is instead of giving you an ordered pair and asking you if it is a solution, we're going to try to draw a picture of every single solution that works for the inequalities that are given to you. Well, if you look at number 3, we have an inequality, and we're going to graph it just like we did with slope-intercept form. If you think back to chapter 5, earlier sections, we graphed lines in the form y equals mx plus b, which is your slope-intercept form. We're going to treat these the same way. We're going to go ahead and graph this line as if it was in that form, kind of ignoring the inequality for right now. So we're going to start down here at negative 3 with our y-intercept. We're going to go up 2 and over 1, and I'm going to continue to go up 2 and over 1, filling in the rest of the graph. I'm then going to go ahead and draw my line, which will be a solid line. Now, that's what the graph would look like if it was an equation, but this is an inequality. So what we're looking at is solutions that either lie above the that lie above the line or lie below the line. Well, the easy test that we're going to do is we're going to take the point 0, 0 almost every single time, and I'll explain later when we won't. But we're going to put 0 in for y, and we're going to put 0 in for x, and we're going to go ahead and solve this inequality. and see if it actually leads to a true statement. When I solve that, I get 0 is less than or equal to -3. And if you picture that on a number line, that actually is a false statement. So what that means is the 0.00 that I substituted into the inequality, it didn't work. In other words, it wasn't a solution. So when I find the 0.00 on my graph, I know that's not the side that contains the solutions. I don't want to shade in above the line because, again, that contains 0, 0, and it wasn't a solution as we just showed. So what we're going to do is we're going to go ahead and shade in below the line. And this area here is going to represent where all the solutions are for this inequality. In other words, when it goes on later in the problem to ask for 2 solutions, honestly, I can pick any points in the shaded region. I'm just going to go ahead and randomly pick, let's say 6, 1. So that's going to represent a solution. Sorry about my pen getting a little bit goofy there, but that says 6, 1. And I'm going to pick another point in the shaded area. Let's just go right here. It looks like that's at 3, -6. So that would be a second point that's a solution. But again, any point in that shaded red area represents a solution. Now, as far as non-solutions, anything over here in the non-shaded area would work. So -6, 4, that won't work as a solution. And let's just go right here at -3, -4. And again, that won't work. Okay? Keep in mind that any point on the line also represents a solution because of the equal sign underneath the original problem. Okay, looking at the next problem now, graphing this one, you might notice that it's in standard form and you might want to use the intercepts method. However, if you picture isolating the y, you'll see that it leads to some fraction work. So we're going to avoid that by doing like we did on the last problem and making it an equation, or actually an inequality in this case, that's in slope-intercept form. And keep in mind, anytime we multiply both sides by a negative or divide by a negative on both sides, we'd have to change the inequality. Fortunately, in this case, we don't have to do that. So this is what I'm going to be graphing. Y is greater than -5/2 x minus 4. So I come down here to my y-intercept of -4. I'm then going to go down 5 units and over +2 units. I'm going to get a couple more points here by going up 5 and back 2, up 5 and back 2, and that should be enough for us to go ahead and do our graph. Now this one's going to be a dashed line because we don't have the equal sign underneath the inequality. So it's going to look something like this. Now again, I know I'm going to shade one side or the other to represent where the solutions are. So I'm going to use my 0, 0 trick. And quite honestly, I can put it into either the original inequality or the new one that I created. I'm going to go ahead and substitute it into the original one here, just because I think it might be a little bit easier to use. And that would give me a 0 plus a 0 is greater than -8. When I finish simplifying that, I get that statement. That is a true statement, which means the side that contains 0, 0, which is right here, that's where my solutions lie because that's where 0, 0 is, and it turns out it was a good solution. So I'm going to go ahead and shade in that side that contains 0, 0, and that will represent the solutions for this inequality. In other words, any point in this shaded region is considered a solution. However, keep in mind, points on the line are not solutions. That's why I have it as a dashed line. Now, as far as writing points that are solutions, once again, we'll go a little bit quicker here. Maybe we'll go with 3, 0. And let's go with 6, -5. 2 points that aren't solution, that would be -5, 0. And we'll go with -1, -7. And actually, if I wanted to list a third one, I could actually pick a point on a line. I could do this point right here, which would be -2, 1. Okay. All right, so all the problems are essentially done the same way. You're going to graph the line, shade in the side that contains 0, 0, and go from there. Now in this problem, there's two ways I can approach it. I could either go ahead and move the 4x and the 2 to the other side, but that would leave me with a negative y and still having to get rid of the negative. So I'm going to take a different angle with this one, or a different approach. I'm simply going to add a y to both sides, which means those will cancel. So with that one simple little step, I now have it in slope-intercept form. So I'm going to go ahead and graph with my y-intercept of positive 2. I'm going to go up 4 units and over 1, up 4 over 1, and that should be enough for me to go ahead and do my graph here. It is going to be a solid line because of the equal sign. And again, using the 0, 0 trick, I'm going to substitute in here a 0 and a 0, so that would be 0 plus 0. And you really don't need to show this work. Oh, I'm sorry, I made a mistake there. Can you correct that? It would be a 0 plus 2. My pen's getting a little bit goofy here, I apologize. So 0 plus 2. There it goes again. But that leaves me with 2 is less than or equal to 0, which is not a true statement. So I don't want to shade in the side that has 0, 0. I want to shade in the side that does not have 0, 0. So that would be over here. And there you go. And as far as 2 points that would work, I'm going to go a little bit quickly here. Let's go positive 2, 0, and let's go 7, 7. And then 2 points. Oh, I apologize. Those are wrong. Those would be ones that didn't work. I want to pick points that are in the shaded region. So let's go negative 2, 0, and negative 7, positive 7. And then for points that aren't solutions, let's just go 6, 0, and let's go 8, 0. The last problem here, a little bit of a tricky part to it. When we go to graph, I'm going to go ahead and start with my y-intercept of 0, and I am going to go up 4 units and over 1, up 4 units and over 1, also down 4 over 1, down 4 over 1. It is going to be a dashed line here. Now, the problem with this is, usually we substitute 0, 0 in to see what side to shade, but if you look, the line itself actually goes through 0, 0. So you can pick any other point you want. I'm just going to randomly go ahead and choose 1, 0 because it's kind of easy to use. And I'm very sorry about my pen acting goofy here. All right, sorry, hopefully my pen is fixed now. But again, I'm going to go ahead, there it goes again. All right, let's try this again. Using the point 1, 0, I'm going to go ahead and substitute the 0 in for the y and the 1 in for the x. Okay, one more time. Using the point 1, 0, substitute that in, and I get the statement 0 is less than 4, which is a true statement. So the ordered pair 1, 0 is here. It did work, which means I want to go ahead and shade in the side that contains that. So here's where 1, 0 was on this side, so I'm going to go ahead and shade this in. And again, this would represent where all my solutions are. So real quickly, I'm going to pick a couple easy points. Let's go with 4, 0, and maybe 6, 6. And as far as non-solutions go, let's go with negative 5, 0, and negative 1, 0. And again, I apologize for that being a little bit sloppy, but you heard what I was saying there. Okay, finally, wrapping things up, there are 4 problems we'd like you to do as classwork. Why don't you pause right now on the video, spend some time doing numbers 5 through 8 on page 418, and then I'll go ahead and reveal the solutions to you here in just a second, and you can check them when you're through. All right, there are the solutions to the 4 problems we asked you to do as classwork. Hopefully today's lesson made sense. I apologize for the problems we had with the pen. Good luck with it.